Welcome to qnawire.
Alright guys, we're going to be doing problem 64, chapter 9 in Chemistry Central Science. So it wants to write a single Lewis structure for SO3 and determine the hybridization of the sulfur atom. So we have our Lewis structure here. We can broadly think of hybridization in this case. If you have two electron densities surrounding you, your sp. If you have if you have two electron densities surrounding you, your sp. If you have three electron densities surrounding you, you have your sp2, and if you have four electron densities surrounding you, you have your sp3. So we have 1, 2, and 3. Even though we have a double bond here, this still technically counts as one electron density. So since we have three electron densities flowing around it, and we don't have any lone pairs, that means that we're going to have an sp2 hybridization. Now, they want to know, are there equivalent Lewis structures for this molecule? Well, yes, there are resonance structures. So the double bond over here, that can go onto here. Or rather, let me show the resonance structure. S. Don't mind this. This was just used to calculate the number of electrons for getting our Lewis structure. If you have 24 electron, as if you have 24 valence electrons, you need to have 24 electrons in your Lewis structure. Now, there are two things that can happen. We can do this, where the electrons from here come over and make a double bond here, while the electrons here go, well, the double bond breaks and we form electrons recede to this oxygen, or we can have it where this oxygen forms a double bond, and this oxygen here, and this double bond breaks and forms the oxygens. So these are our two different structures. That's wrong one. So we have the bond on the right oxygen, and on the red we have So in this case, we have the double bond on the left oxygen and single bond on the top and the right oxygen. So these are all resonance structures of one another. So since we have resonance structures where you can have a double bond on each of these oxygens in a specific resonance structure, that means that you are going to have delocalized pi bonding. You are going to have a partial double bond character on each of these as you are going to have partial bond on each of these SO bonds. And that's going to be this. But in fact, we don't need to draw the Lewis structure. We can just draw it without showing the electrons. So we're going to have partial double bond character here and here.